Hey, it's Mr. Alry, and we're going to do a couple of factoring practice problems here, and these are ones that use some of our special rules, so they're special cases. The first one here, 36x squared minus 16y to the fourth. So our special rules either deal with squares or cubes. Since I look at these two numbers and they both look similar to perfect squares, let's see if I can rewrite that. So I'm going to try and write the first number as a perfect square. It's going to be a subtraction. So I'm trying to write the second number as a perfect square. So 36 is 6 squared, and x squared is has a square root of x. So I can write the first one as the quantity of 6x squared. 16, square root of that is 4. Square root of y to the fourth would be y squared. So in this situation, I have an a, and I'll write the formula out in a moment, of 6x, and a b of 4y squared. So I have an a squared minus a b squared. Now that formula is a squared minus b squared equals a plus b times a minus b. So we've looked at the left-hand side of this for our formula, so let's write out the right-hand side. So that would be a plus b, which would be 6x plus 4y squared, and then the minus of that, 6x minus 4y squared. An interesting thing here I was not expecting is I can pull a 2 out of each one of these if I want to. So I've done the difference of squares, but looking at this, I can pull a 2 out of the first one, a 2 out of the second one, so really I can pull a 4 out front. So if I pull a 2 out of the first one, it will be 3x plus 2y squared. And if I pull a 2 out of the second one, it will be 3x minus 2y squared. Okay. So let's see. The second one here, 343m to the ninth minus 64n cubed. So these are odd numbers, so if one of these formulas is going to work, it's probably going to be a cubed formula. So let's see if we can get a cube on both of these. So let's see if we can write the first one as a cube. It looks like it's going to be a difference. So we'll write that formula down in a moment. But you might take a little bit of work to figure out what you've got here because you might not be familiar with these numbers. But the cube root of 343 is 7, I believe. You can try that on a calculator or do a factor tree. Cube root of m to the ninth, if you say 3 into 9, you'll get 3 times, so 7m cubed. Cube root of 64 is 4, and 3 into 3 on the n to the third is just n. So we have 7m cubed, all cubed, that would be our a, and 4n for our b would be 4n cubed. So writing out the difference of cube formula, let's get rid of that. Writing out the difference of cube formula, so we'll see how to put it together, is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So I know it's lengthy, and we've got a lot of terms here, so we'll just kind of hope for the best, but if we follow the template, it'll work out. So a minus b, that'll be 7m cubed minus 4n. And then a squared, so 7m cubed squared would be the square of 7, which is 49, and m cubed squared would be m to the 6th. A times b, so that's 7m cubed times 4n, so that'll be plus 28m cubed n. And then b squared, b is 4n, so that'll be plus 16n squared. And while that's fairly lengthy, you could go back and we'll use a distributive property on this, multiply everything out, and some like terms should cancel out and give you exactly what you want. Okay, one more example here. Let's see here. 27x cubed minus 216y cubed. Once again, these are cubes. I just did a difference, so let me change this to a plus up here. That is hopefully what I meant. Let me also change it on my paper. So when I go type it up, it'll look right. So we're going to do 27x cubed plus 216y cubed. So as I was saying, we probably want to write these as two perfect cubes if possible. We may not be able to, but it will be the sum of cubes. So cube root of 27 is 3. X cubed is just x when you take the cube root. 216, the cube root of that is 6. And y cubed, the cube root of that is just y. And you can always use your calculator to make that happen. But what we have here is an a of 3x and a b of 6y. So the sum of cube formulas looks like a plus, did it again. If we have a cubed plus b cubed, which is what we're looking at, a cubed plus b cubed, would be a plus b times a squared minus ab plus b squared. And those are a little hard to remember, but jot them down somewhere. Usually I'll let you use them on a test if it's needed. But let's see here. A plus b, that would be 3x plus 6y. And then the second part here, a squared, so 3x squared would be 9x squared minus ab, so that would be minus 18xy plus b squared, so that would be 36y squared. So maybe there was a common term I could pull out in the front. I really wasn't paying attention. I know I can pull a 3 out of the first one, so that would be x plus 2y. And it looks like I can pull a 9 out of the second one. So let's see here. That would be x squared minus 2xy plus 4y squared. So I'm not sure how I messed that up. Maybe I should have pulled a 27 out from the beginning. I'd need a calculator nearby if I was going to do it, but it looks like I could have pulled 27 out from the beginning. So, and that may have made things easier if we noticed there was a common term, but when I put these down, I was thinking both of these things were perfect cubes, so it would work out. So in a final factored out as much as possible form, we have the bottom. Thank you.